TV Library. Today we'll be learning about the periodic system of chemical elements. The periodic system is a table that classifies the chemicals on the basis of their properties. The question is, how was that table developed? Let's imagine now 3 students discussing the development. The young student Lloyd describes the roots of chemistry. Now, let me explain the beginning of the conceptual development of chemistry that we can see observed in the periodic table. Aristotle's belief that all substances were composed of the 4 elements of water, fire, earth and air was a very different model to that we know as the periodic table, but it was most certainly the beginning. According to Aristotle, the ancient practice of alchemy was very important. It was all about creating gold, as gold was the purest of all the metals. His not so very clever fellow student Peter asks, "What's gold got to do with the periodic table?" "Peter, it's not gold, it's alchemy. It's the process of alchemy of refining metals and turning them into gold. When it takes a substance, degrades it, transforms it and transmutes it," said Lloyd arrogantly. "Okay, then I get it, but where does the classification process come in then?" replied Peter. "Listen, it's very simple. Alchemists composed and separated materials. Therefore, the notion of classification arose. The evolution started when scientists understood that some simple substances, which cannot be separated into simpler substances, exist and form the basis for compound substances." Lloyd was an exceptional geek and continued in his explanation. "Yes, but it was through the development of the periodic table that scientists understood that some simpler substances could not be separated and transformed. So, there are some elements that are pure and cannot be broken down." A fellow young scientist, Katie, joins in the discussion. "Well, Lloyd, I think you're failing to mention which scientist discovered this, that being Robert Boyle. It was Boyle that contributed greatly to this idea in his monograph, The Skeptical Chemist. He said, roughly if I can recall, 'I have come to understand that elements, that simple substances which have not been mixed with another substance, are the ingredients of perfectly mixed substances, are compounded and into which they are ultimately resolved.'" So all the elements are pure and can't be broken down, replied Peter. "Yes, indeed. Whilst elements become some sort of standard in chemical argumentation, it remained unclear what elements are and what compound substances are," said Katie. "You mean that they could not understand the difference between elements and compound substances?" asked Peter. "Yes. Air wasn't considered to be an element until well into the 18th century. That's when many chemists started to study pneumatics and were able to show that air was a combination of several gases," said Katie, but Lloyd interrupted. "Oh wait, but you've forgotten that at the end of the 18th century, Lavoisier classified the elements according to their properties. So, materials with similar behaviour in chemical reactions were classified as similar. Lavoisier classified his elements into metals, non-metals, earthly substances and simple substances. But this organisation is not classification. But to understand how the periodic table developed more clearly, it is important to understand how the works of Dobereiner and Newlands in their creation of the division of the elements." Lloyd continues. "The most important scientist in the development of the classification of chemical elements was pharmacist Johann Wolfgang Dobereiner. From his experiments, he noted that there are several groups of 3 chemical elements that behave very similar to each other in reactions. He could find several combinations of elements, and according to him, there was always 3 elements. Now Katie was keen to show off that she knew more. Yes, but can you quote the words of Doberan? Because I can. He said, most notably, calcium, strontium, and barium did not just show a similar behaviour. Moreover, their masses had a certain ratio. The mass of strontium being the mean of the ones of calcium and barium. Did you even understand what I said? She laughed. No, replied Peter. This was Doberan-Reiner's discovery of what he called the triads or triplets, which he published in his article called Annalen der Physik. In that article, he wrote about being able to form 10 groups of triads out of the 50 elements that they knew to exist back then. Said Katie. Another researcher who developed a systemization of the growing number of chemical elements was the British John Alexander Rayner Newlands, who published his works in the 1860s. Lloyd was also fascinated by Newland's observations. Actually, Newland said that if the elements are arranged in order of their equivalence, with a few transpositions, it will be seen that elements belonging to the same group appear in the same horizontal line. Also, the numbers of the similar elements differ by 7 or multiples of 7. Oh, what are you going on about? Peter still didn't understand. It is what he called the law of octaves. He put the elements into rows of 7 with the same group of elements appearing on the same horizontal line. Newland's theory had limitations because he looked at the elements through their mass, and he understood that there were irregularities that his theory could not account for. So this realization changed the systemization of the elements, as the atomic mass could no longer categorize the element. Newland related this structure of the elements to the musical octaves. A combination of musical and scientific systems of classification is not as uncommon as it sounds. Kepler used a similar approach for the planets in the solar system in his Harmonia Mundi. Now, let's get back to the students' debate. At the end of the 1860s, 2 different researchers independently came up with a very similar approach to arrange the chemical elements. Who did that then? Asked Peter. Oh, let me explain, Peter. It was Mendeleev and Mayer who worked on the development of the periodic table. There are some differences between Mendeleev's table of elements and the modern periodic table, but the main difference is the differentiation between main groups and secondary groups of elements. Additionally, there are no noble gases. They did not exist in either Mendeleev's or Mayer's system, said Katie excitedly. Then Peter sat down and reflected for a moment. So you're telling me that the periodic table evolved from alchemy when in Aristotle's day they wanted to change ordinary metals into gold, therefore understanding categorization of elements. Then Boyle came along and figured out that there are pure elements as well as compounds. Lavoisier divided them up according to their properties, and Doberan-Reiner divided them up into groups of 3. Which were made up of elements that behaved the same. Then Newland came along and put them into groups of 7 and ordered them into a horizontal line. A bit like music, like a music score of the elements, man. Then Peter sat and reflected for a moment. What you both have not mentioned is that the most important scientist in terms of classification of elements is in fact Mayer and Mendeleev. Mendeleev? Yeah, Mendeleev. Both researchers independently came in to a very similar systemization pattern of elements. Consequently, the Royal Society in London awarded the Copley Medal to both of them. Evidently, there are some differences between Mendeleev's table of elements and the modern periodic table, a main difference from the non-existent differentiation between main groups and secondary group elements. Additionally, there are no noble gases. They do not exist in either Mendeleev's or Mayer's system. Moreover, the system contains some open positions. So Katie and Lloyd were shocked. But Peter had not quite finished. He continued. Mendeleev's system consisted of 3 additional suspected elements which had the atomic mass of 45, 68 and 70 respectively, and a few years later these fictitious elements were identified and named gallium, scandium and germanium. The open positions of Mendeleev's system, where no element could be placed, served as predictor for elements that had not been noticed until then, and all the previous attempts to create an order for the chemical elements had not had the potential for such a prediction.